Hey folks, I'm Saeed, the Codogrammer, and in this video we're going to look at something called code blocks in Java. Now this is a slightly lesser known feature. I think a lot of Java developers don't know about it, or if they see it they think it's bad form, or maybe they're just not used to seeing it. But yeah, it is something you can do in Java, so we're going to take a look now. So let's dive straight in and say that you can create code blocks in a few different places. As I mentioned earlier, not many developers are aware of them. So let's take a look at an example. We have a class here called 01 blocks basics. So here we just have some curly braces with some code directly in there. There's no signature, there's no return type or anything like that, not a method name. So this is not a method. This is what we call an initialization block. And it's essentially used to initialize this class when you create a class, okay? And we'll go into more detail about that in a bit, but here is a static code block. So this is a non-static code block, a class initialization block. And here is a static code block. The only difference between these two is that one is static and one is not static. This still doesn't have a return type and it still doesn't have a signature. All right, so why do we need code blocks, or why do they exist? Well, instance initializers, these can be useful for repeated code in constructors. So when you're creating a class, you can move some of the code that you've got in your constructors into instance initialization blocks. They can be useful for anonymous classes, which can't have constructors, and we'll go through that in a little bit. Now, static initializers can be useful if you want something to happen before the class is loaded, before any instance is created. Now, static initializers can be useful if you want something to happen before the class is loaded, before any instance is created. But you can also have code blocks inside methods, and this may be useful to create scope. But you could just call another method instead of creating a code block inside a method. All right, so let's have a look at some more examples and we'll see when they run. So here's another initialization block. So obviously you can have more than one. Here's another static one. So you can have more than one static one. And here is a constructor, which is what probably you're used to seeing for this class. Okay, here's a standard main method, and let's just minimize this. And here's an arbitrarily nested code block. So don't worry about that. We'll talk about that in a second. So let's just run this class and see what happens. So you can see that it printed the static ones first, even though they weren't next to each other. They had an instance initialization block between them, or some other code between them, but it still ran static 1 and static 2 first. Then it ran the instance level code block. Then it ran instance, let's see where instance 2 comes in. Yeah, then it ran instance 2, which is another initialization block. Then it ran something called arbitrary nesting, which is this kind of heavily nested code block here, or multiple code blocks. Okay, and then it ran the constructor. So that gives you a hint about, or an idea about, what order these things run in. First of all, you get the static initialization blocks. Then you get the constructor call, but the constructor behind the scenes, the constructor calls the initialization blocks, and then anything else happens after that. Okay, now let's just touch on the arbitrary nesting here. I can't really think of a reason why you'd want to create a code block inside a code block, inside a code block, inside a code block, but just in case you want to, now you know that you can. All right, so let's move on to the next section of code blocks. Now, you've already seen the kind of order in which they run, but let's just go through in a bit more detail. So let's go through in a bit more detail. So when do they get called? Instance initializers, those are the ones that are not static and they're not inside a method. They're called from within the constructor after the super call. So the first thing inside a constructor, whether you see it or not, is a call to super, which is a call to the super constructor. And instance initializers are called straight after that. Okay. So you might ask, well, if we can use a default constructor, then why do we need instance initializers? Sometimes you have multiple constructors and you have the same code, a lot of the same code repeated in each one of them because they need to do similar things. Well, that code can be moved to instance initializers if you want to. You may or may not prefer this to calling a method. You could just call another method to do some sort of initialization for you. But one advantage over calling a method is that you don't need to remember to invoke the method if you add more constructors, for example, because Java automatically calls the instance initialization blocks for you. So if you're worried that your class, somebody might come along and add more constructors to it later and they'll forget to call some method that needs to do some setup work, you could put that in an instance initialization block like this, for example, and then Java will call it for you. All right, so let's give that a whirl and see what it looks like. All right, so you can see that something repetitive ran first. Okay, we don't have a static block here, so you don't see that. Then you see that the constructor executed. Then it calls the do something method. All right, so let's go ahead and run some of this code to see what kind of order things run in. So we've got a static block here, and we've got an instance initialization block here. We've got a constructor, and then we've got a method that we're calling to do something repetitive, for example. And we've got another constructor here, constructor 2, and then in this main method we are constructing an instance using constructor 1 and constructor 2. So let's just see what that looks like. Let's just run that. Okay, So first of all, it ran the static block one, and notice that that only ran once. It didn't run it twice because, now notice that that only executed once. The reason why that executed once is because static things are not related to individual instances, but the actual class when the class gets loaded into Java, and then it executes that static block, okay? Then we see that something repetitive is printed because that's a initialization block. Then we see constructor 1 is executed. Now, it looks like constructor 1 is executed after this instance initialization block, but that's only because there's an invisible thing here which calls super, and after calling super, it calls this initialization block, and only then it prints constructor 1. So in reality, these should be kind of in the other order, but that's just happening behind the scenes. Then we call do something, okay, and that prints out something. Then we call constructor 2, which is here, but don't forget that this calls something repetitive. So, and again, this is kind of in the wrong order, but that's just the way Java works, okay? Because in constructor 2, before printing out the constructor 2 statement, it's actually called something repetitive, and then it prints out this statement, okay? So hopefully that gives you a good idea in terms of the order in which these elements execute. All right, so let's move on to the next section. So one of the other ways in which initialization blocks are useful is when you have anonymous classes. Anonymous classes are classes where you don't give the class a name, but you implement it kind of on the fly. So let's have a look at an example. We've got an interface here called cat, which can meow and purr. And if you're interested, this is not a functional interface. I won't go into more detail about why that's important, but if you're interested, leave a comment in the comment section below and we can discuss it there. All right, so this method is just created so we can demo our example. We have a method here called method takes anonymous class, and this one takes an instance of cat. It doesn't do anything with it, but that's because we don't really care for the purpose of this example. But how do we pass a cat? Because we don't actually have an instance of cat. We don't actually have a class for an actual cat. In fact, we have an interface and we can't create a new interface instance. But actually we can, because we can create an anonymous class. So this class doesn't have a name, but we're saying new cat, and then we're implementing the abstract methods meow and purr as we go along on the fly. So you can see here that we can implement meow and we can implement purr. Okay, they don't do very much, but that's enough to demo our example. So here we've got some instance state in this class. Now we want to initialize that, for example, before any of these methods run. Now I'm not saying anything about whether this is good design or bad design. This is just to show you what code blocks can do. Now if we said we want to do that in the constructor, we could create a constructor like that, but oh dear, we get an error, invalid method declaration, return type required. And we know constructors don't have return types. So unfortunately, we can't do that. It's not allowed. But instead of that, we can use an instance initialization block to initialize our value to 10. All right. Now, just to prove a point, we can also have a static code block here. So let's actually execute this by adding a main method. All right, let's run that. If you're wondering why I got those kind of lengthy code suggestions in my IDE, that's not something that IntelliJ provides directly. That's coming from GitHub Copilot. So I won't go into more detail about that now, but I am going to be making a new video about GitHub Copilot very soon. And so make sure you subscribe if you are interested in that. All right, so let's just kick this off now. Okay, you can see that that prints out static, which shows that this code here was actually executed. We didn't actually run any of these other methods, so it's not going to actually print those out because we don't do anything with the cat, but that's beside the point. You can see that this compiles and was executed successfully. So that shows you where code blocks can be useful in anonymous classes if you need them, all right? I'm not sure in 20 years of Java development I've actually needed to do that, but just in case you do, now you know you can. All right, so let's move on to the next section. All right, so in Java, you can have blocks with labels. Let's look at an example here. So here we have a code block inside a method. Now, just to prove that you can have code blocks without labels, let's just create a code block here and just put, there you go. Okay, so that shows you you can have code blocks which are not labeled, but you can also use this kind of syntax to label a code block. Now you might say, well, why do I actually need to label a code block? What could be the possible reason? Well, it may be that if a certain condition is true, you want to actually jump out of that block. So you don't want to execute anything after you break meaning jump out of that block, because there's some extra code here which only applies if this condition isn't true. Now, obviously this condition is always going to be true. It's just for the sake of demonstration, but you still want to run everything else in the method, just not everything else in that block. It's kind of something like you might do it in a loop. Okay, so let's just run that and see what happens. All right, so you can see that it prints out before block, which is that one, which is the top one. And then you can see it prints out inside block, which is just our plain code block. Then it prints out blah, but because 1 equals 1 and we break out, it doesn't print foo. Okay, you don't get any foo there. But then you still get the final statement from the method. So it still continued to execute inside that method. All right, so that's another thing that you can do. Now, personally, as I've written here in my notes, I would move this to a private method, but it might be good to know that you've got this option. All right, so another thing to bear in mind is that you cannot have labels at the instance level. So I'll comment that out. You get an error. You can't have them with statics either. All right, but you can have them inside an instance block. Okay, so if there's a code block, then inside that code block, you can have another code block which does have a label. And that's the same for static. So you can use that for a little bit of scoping and that kind of thing. And if you wanted to break out of that loop. So this label here isn't really useful. And you do get a message saying it's an unused label. It's only really useful if you're going to refer to that label afterwards. All right, so let's move on to the next section, which is blocks with exceptions in the constructor. Now you can catch exceptions in blocks just like you can in a constructor, and the same in static initializers. However, you can't throw them from a code block. All right, so let's just have a look. And this is another one of the differences between code blocks and constructors. So here we have a code block, which initializes this variable, creates a file, and catches a file not found exception. It's able to catch that and it's able to print stack trace, much like you can do in a static initialization block there, and much like you can do in a constructor. All right, all good. But if you decided, look, you didn't want to catch this, and instead you want to throw it, you can just do this and it will say, do you want me to add this to the method signature? And you can do that and happy days. All right. But if you decided you wanted to do that from a code block, suddenly you might find out that the situation is a bit different. So let's just comment that out and see what it looks like. All right, now we open up our suggestions and you just get the suggestion to surround it with a try catch. You don't get the option to throw it because there's no real method signature. There's no way to actually declare that. So that's not something we can do. And the other couple of obvious differences, there's no parameter declaration. So if you want to pass parameters to these code blocks, you can't. And if you want to declare an exception, you can't. And if you want to give it a name, you can't. All right, so these are some of the limitations you have over standard constructors or external methods. All right, so that pretty much concludes this video on code blocks in Java. Let me know if you already knew about code blocks. I've been coding in Java for a very long time, and it's very rare to see somebody actually use code blocks. I'm pretty sure if I use them, somebody would raise their eyebrows and ask why, or be confused because I haven't seen them before. So let me know if it's something that you've used, something that you knew about. If you agree or disagree with their use, let me know in the comments below. And if you're interested in being kept up to date with the latest software development news and information, make sure you hit subscribe. Thank you for watching.